We're talking about working with polynomials, and for adding and subtracting, like terms covers our bases, but what about for multiplying and dividing? Well, just to deal with multiplying for the moment, what we would want to do is try to start with the most basic, smallest kinds of problems and work our way into those larger, longer polynomials. So we'll start with if we just have monomials. Two monomials that we multiply together, what would happen? Well, the example that we've got there, negative 8x squared y to the power 3 times 3x to the power 4 y. In order to multiply things together here, what we want to do is take the coefficients and multiply those together, and that'll give us a negative 24. Then we're going to want to put our x stuff together. Well, our x stuff, x squared times x to the power of 4, means that from our rules of exponents, our properties of exponents, we're going to add those powers together so that we would have x with a power of 6. And then, in fact, that same rule for our y business, y to the power of 3 times y, remembering that the y has a power of 1, we add the power of 3 to the power of 1, and in our final answer, y has a power of 4. So if we can do these monomial problems, we can now try to step up and do multiplying with longer problems, with longer expressions. So we're going to bring in something basic that we've been using a little bit here and there for a while, the idea of distributing. So this example that we've got here at the bottom of the screen is going to be one where we would distribute. That's where we would still have a monomial that appears, and the other part of our multiplication problem is something that has more than just one term. So this example here, we've got 3 terms inside our set of parentheses. We're going to want to take that monomial from out front, that negative 3t squared, and we're going to want to attach it to each of the terms inside the parentheses. So the negative 3t squared times the 7t to the power of 3, the negative 3t squared times the minus 2t from the middle, and the negative 3t squared times the 3 at the end of our set of parentheses. What we've created here are 3 smaller multiplication problems: multiplying monomials, multiplying monomials, multiplying monomials. So number stuff times number stuff, negative 3 times 7 is negative 21. Take your powers and add them together, t to the power of 5. Number stuff times number stuff, negative times negative is a positive. 3 times 2 is 6. And then add the powers together for our t stuff to get a power of 3. Negative times a positive gives us a negative. 3 times 3 is 9, and we only have t squared, so that's the only variable stuff that is showing up at the end. And just to cover our bases, let's make sure that we don't have anything else to do to shorten this answer. So we don't have any like terms that we can combine together to shorten things, which means that this is the best and shortest answer that we've got for this particular multiplication problem. Stepping things up from here becomes a bit more complicated. So if we step things up just a little bit, turns out that there's a nice pattern to the way that a particular kind of multiplication problem would work out. So backtrack up here to where FOIL is mentioned. If I have a binomial, 2 terms, times another binomial, 2 terms, 2 terms, 2 terms, multiplying those things together, there's a pattern here to how that would work that connects to this acronym of FOIL. first, outer, inner, last. The first term from each set of parentheses, first times first. The outer terms from the entire multiplication problem. So what's at the very, very front, what's at the very, very end, multiplied together. Inner for what is the two inner pieces of the entire multiplication problem. And then L for last, referring to what's the last term of the first set of parentheses times the last term of the second set of parentheses. Take a look at an example here so that you can see what's going on one little piece at a time. So in this next example, notice that first set of parentheses, 2y minus 5, that's two terms. Second set of parentheses, 4y plus 3, two terms. Binomial times another binomial, we can use FOIL. So, the F part of FOIL refers to the word first. The word first more specifically means take the first term from each set of parentheses. The first term in the first set of parentheses, 2y. The first term from the second set of parentheses, 4y. If we go ahead and multiply those together, we would get 8y squared. The O part of FOIL refers to the word outer. Outer more specifically refers to when I look at the entire multiplication problem, I want to take the outside terms, what is on the front outside and what is on the end, back end outside. So 2y times a positive 3. And if I go ahead and multiply those together, I'm going to end up with a 6y. Then the I for inner. Inner is referring to, again, the entire multiplication problem and the two terms that are innermost. So that means that we have a negative 5 times a 4y. And that seems to be working out as a negative 20y. Then we've got the L part of FOIL. Give ourselves just a little bit more space there. The L part of FOIL, L referring to last, last referring to what's the last term from each set of parentheses. Last term, negative 5. Last term, positive 3. So, negative 5 times positive 3, and that seems to be working out as a negative 15. Now that's just putting those four separate pieces together one at a time. We need to know how all of them are connected to one another. And so what we do is we start out with, well, the most straightforward thing to do is just have all of them originally being added together. So the F plus the O, well, the O stuff was positive, so it's going to stay positive. The I stuff was negative, plus a negative, well, I can just say minus. So minus 20y, just go ahead and move that over so they're a little closer together. And the L stuff was negative, plus a negative could just be written as a minus, so minus 15. Now remember that, again, we want the shortest, most direct answer that we can possibly provide. So it's a good idea to look through and see if there's anything else that we can do to shorten our answer. Specifically, that means that we're looking for like terms. Only one that has a y squared, so that's good to go. That's got a y, that's got a y. These two middle terms can actually be combined together to shorten our answer up. So that plus 6y and minus 20y would come together, and our final answer would start with 8y squared. Then in the middle, our like terms combine and give us a minus 14y. And then our constant at the end. So we've managed to shorten that answer down so that instead of 4 terms, F-O-I-L, we've actually put the O and the I parts together and gotten a trinomial here as our answer. Now, that's something that we want to keep an eye out for. Not all FOIL problems will have some like terms to combine, but there are plenty of them that do. You want to make sure that you're on the lookout for exactly this sort of thing. If you don't combine your like terms, you're not going to receive full credit for that answer because it will not have been as simplified as possible. So make sure that you're on the lookout for that. Now, there are longer multiplication problems that could have more than just 2 terms in each part of the multiplication problem. And in order to deal with those, we can actually take 2 different plans of attack. One way of working through things, which you see peeking up here at the bottom of the screen, one way of working through things would be to take the FOIL idea and sort of expand on it so that you would have this kind of rainbow effect. The first term has to combine with all of the things that are in the second set of parentheses. The second term has to combine with all the things that are in that second set of parentheses. And for a lot of folks, that looks a lot like trouble because there's a lot of stuff to keep track of unless you've got a lot of different colored pens or pencils. So coming up with your final answer based on all of those rainbow pieces might be a little bit more work and effort than you would like to put in. But as we work through things, we do at least get all of the pieces that we need. But they're all out of order so that we would have to still worry about combining like terms in order to get our final shortest, simplest answer. So following the normal convention that we mentioned before, the highest power that appears is a power of 3. Only one term has an x to the power of 3. Moving down to the next lowest power is power of 2. There are 2 terms with a power of 2. Combining them together, we get a plus 4x squared. Dropping down our power again to a power of 1. Power of 1 is not normally written, so we're looking for really just a plain old x. There are 2 terms with a plain old x in them. We combine those together to get a plus 11x. And then there is only one last term, which is just a plain old number. So the final answer here, doing this rainbow method of working through things, should be the same answer as the other plan of attack would give us. Now notice in this other plan of attack, what we've done is we've rewritten the multiplication problem so that it looks a little bit more like a traditional multiplication problem that had numbers in it. And what we can try to do is use the same basic plan of attack with multiplying numbers, like if we had a number that was 498 times 37. Try to use the same sort of plan of attack and see if it works for these polynomials. Turns out it actually does. So what we're talking about here is take the end of the second polynomial and multiply it by what's right up above it. That would give us a plus 21. Take that number at the end of the second polynomial, multiply by what's in front of that 7. So 3 times a negative x would be a negative 3x. Take that number at the end of the second polynomial, multiply by what's in front of that x. So 3 times 2x squared would be officially a positive 6x squared. Now I've completely used that 3 that's written in pink. Now I want to use what is in front of that 3, which is a purple 2x. So take that 2x, multiply it by the end of my first polynomial. 2x times 7 is a plus 14x. And when I write that in, I want to make sure that I skip the spot underneath the 21, because we always leave that blank and move over 1. That's what we do with our normal multiplying. Notice what happens is that plus 14x is automatically getting put into the same column as the other x stuff. So it's automatically getting sorted into a column of like terms. The 2x times what's in front of the 7 is a negative x. So that's going to give us a negative 2x squared. Notice that that's automatically going into a column where like terms appear. And then the 2x times what's in front of the x is a 2x squared. That's given us a plus 4x power of 3. And then once we were done with all of those multiplying steps, we said we take these rows and we add them together, starting at the far right column. Plus 21 in front of that, plus 11x in front of that is a plus 4x squared, and in front of that is a 4x power of 3, and those exactly match up with all the terms that were in our answer from the rainbow way of working things out. So you have a choice of whichever way you would like to go for the few problems that you might have to work out where you have longer polynomials than just 2 terms. The other thing worth mentioning in regards to multiplying would be the special kinds of multiplying problems. And the first example here that I have refers to what we call conjugates. Notice that in that formula that's starred there at the top of the screen, you have a binomial in the first set of parentheses that's almost identical to the binomial in the second set. We've got an a plus b, we've got an a minus b. So they have the same first term, they have the same second term, except one's got a plus in the middle, the other one's got a minus in the middle. So almost identical. That's special. It's special not just because of the way that it appears, but it's special because of what works as you work through the multiplying. It's special because of the answer that you get. This is something that you'll see later on. Again, if you go deep enough into algebra, you find that multiplying conjugates is a very handy sort of thing to have. So the first example that's already worked out up there, x plus 2 times x minus 2, or to be a little bit more careful, parentheses x plus 2 times parentheses x minus 2. What my formula here says is that I could take the first term x, square it, take the second term 2, square it, slap a minus in the middle, and tidy that up and get my answer. You're welcome to do that, or you could also just FOIL things out and still come up with exactly the same answer. So the other example that we're going to work out now, 8ab squared minus 1, and in parentheses 8ab squared plus 1. Because these are conjugates, our formula tells us that we could take the first term, 8ab squared, and square that. 8 squared, 64. A squared, well, there it is. B squared, and square that bad boy means take those powers and multiply them together to get b to the power of 4. Got a minus sign in the middle there. The other part of my answer is going to come from the second term being squared. The second term is just a 1. 1 squared is 1. Now again, you can come up with exactly the same answer if you went ahead and foiled the original problem. So if you use FOIL, you will work out exactly that same answer. So you don't need to memorize that formula if you do not want to. The same thing goes with the other two formulas that are mentioned here. These refer to perfect squares because we have parentheses squared. You're welcome to use the formulas that appear here. If you do not want to remember those formulas, you can get the answers by, again, foiling those problems out. So 4x minus 5y parentheses squared, since that really means 4x minus 5y times 4x minus 5y, I could just go ahead and FOIL that and I would get my answer. But just to show you the formula, what it says and how it works, replacing the formula with these blank spots, I want to put the right pieces into the right spots. So the formula says the first empty spot gets the first term. The next empty spot gets the first term. The third empty spot gets the second term. And the last empty spot gets the second term. So if we go ahead and tidy things up, 4 squared, 16, x squared. In the middle, we've got a minus. We've got a 2 times 4 is 8, 8 times 5 is 40. And we have both an x and a y in there. And at the very end, we've got a plus. 5 squared is 25, and y squared. Again, you'll get exactly the same answer if you have taken the problem and worked it out using FOIL.